Welcome to Corel Designer Technical Suite X5. This video will demonstrate an efficient workflow that integrates Corel Designer X5 and Deep Exploration CSE. First, we'll launch Deep Exploration directly from Corel Designer, import existing 3D model data, and create a simple keyframe animation. Then we'll use the same 3D model to generate 2D illustrations that export seamlessly back into Corel Designer for the best of both worlds. In a separate video, we'll continue this workflow in Corel Designer to create compelling illustrations. If you are new to Deep Exploration, we recommend you review the tutorial in Corel Designer under Help, then select Importing 3D Models for the basic. From Designer, launch Deep Exploration by selecting File, then 3D Import. All features demonstrated in this tutorial in the Corel Standard Edition will import basic 3D formats such as Autodesk 3ds, Google SketchUp, and VRML. The Corel CAD Edition, or CCE, is compatible with nearly all CAD formats and offers many more editing capabilities and panels not shown here. Let's import an Autodesk 3ds file. The file type specific import options will appear, and we'll accept the defaults. Because we'll be enhancing and creating animations, let's save the file in the native right hemisphere RH format. Notice the Reload Saved file is selected to keep the source file unchanged. Saving the file is not a required step if you only need to create illustrations for Corel Designer. However, since we're going to create animations, this is an excellent format that provides very efficient compression with minimum file size. Let's set our view to left top front and move things over a bit so we have room for our animation. Now let's create an animation to remove the camera lens with a rotation, then a move in the y-axis. Select the Animate tab in the Layout Manager so we have the right tools showing. Next, create a new sequence in the Animation panel. This will store the animation sequence we're about to create. If there are other sequences in the list, don't forget to select it and activate it. The first one created will already be activated by default. Next, click on any object of the lens and use the scene tree to select the parent for the lens. Now select the Rotate button, and 3 circles will appear around the object's pivot point. If for some reason the circles aren't visible, or you later notice they rotate on an eccentric, use the pivot point buttons to adjust as needed, or right-click on your selection and choose Move Pivot Point to Object Center. Also notice that the coordinate system is likely on L for local. If you find that several selected objects have separate coordinates, then you may see several axes, so use P for parent if that's the case. Now select the Record Keyframes toggle button on the Animation Control panel. Take notice of the animation icon. This icon will also appear next to any parameter that can be animated, and there are quite a few as you'll discover in time. With Record on, the viewport will be highlighted in red with the REC displayed in the upper right corner. Now move the slider to frame 15. Hover your mouse over the blue y-axis, then click and drag the mouse upward to unscrew the lens as needed. With Record still active, move the slider to frame 30. Now select the Move button and select and drag the y-axis handle to pull the lens away from the camera body. Select the Record Keyframe toggle to turn off Record. When we use the slider to check our animation, you'll notice the Rotate and Move animations overlap. To fix this, open the Animation Timeline from any panel drop-down. With the lens still selected, click on the position part of your animation. If you don't see the whole plot, right-click on the graph and use either Fit Horizontally or Fit Vertically. Since the move is happening too soon, you can see how the graph of Y position in blue is linear for the entire time. So let's add a keyframe by selecting frame 15, then right-click on the new vertical line and choose Insert Key. Now select the Y-axis key, then again select and drag it up until the line is horizontal on the left half. This causes the move to start at frame 15 after the rotation is complete. Again, use the slider to verify this change. Let's hide the animation timeline and position the camera so it all fits in the output frame shown by the dotted lines in the viewport. We can now create a step to save this adjusted camera view, then simply drag and drop our animation sequence into the step container. Click the new step and the animation will play using the saved camera position for the step. Worth mentioning, if you right-click on the step, multiple steps, or even whole procedures, you can render any of these to AVI or other video formats defined by the codecs available on your computer. Let's again save our work in the RH format. So far, we've set up our 3D media to create our animation in deep exploration. Changing gears, let's move on to creating 2D illustrations for print or web. Again, make sure the view is set to orthographic, left top front, as shown, and perspective is turned off. This way, we can continue to draw objects in Corel Designer to easily match the three surfaces using the default angles. We'll reset our animation to the start and use the basic mouse controls on the viewport to center our model in the output window. To export as a 2D vector image, select the render layout and click on Send to Corel Designer. This brings up several options, starting with line thickness. We'll set line to 0.18 and boundary to 0.35, which are a function of your output size setting below. These settings also affect the outcome of the thick and thinning methods in the Advanced tab, as we'll describe shortly. When Show Output Size is selected, the viewport will display either vertical or horizontal dotted lines that correspond to the current aspect ratio as a way to verify that the illustration is within the output area and is not cropped. Now select Render to generate the vector output. When it's complete, the illustration will be automatically placed into Corel Designer. However, since both applications are still open, you may need to manually switch to Corel Designer. When it's done rendering, switch to Corel Designer to see the output. Tolerance angle determines where lines are drawn based on the angle between faces or surfaces. A higher number, such as 75, will have the effect of reducing the detail, while a lower number, such as 25, will generate higher detail. Comparing these three examples shows how the level of detail changes with the various angles used. The Advanced Options allows us to select the thick and thinning method to create different visual effects. The default is Pop Line, which will tend to draw thicker lines on the outside edges of objects to give a more 3D effect. Silhouette will place a thick line around objects, and finally Complete will make all lines thick. Here's how they all look when rendered using the three modes described. If we zoom in on the details, you can see the difference between Complete, where all lines are thick, Pop Line, which is a mix of thick and thin, and Silhouette, having the thicker outline. If you also want fills, the Flat Fill option will render them as a vector fill, in addition to the line settings above. This can be useful if you want to change the color of specific areas of the illustration, as we'll demonstrate in the next video tutorial.